Hi there, we're going to go through a question from a student about integration. So integration is a way to go back to the original equation, or it's a way to find the area under a curve. So we've had a session on it and the student's done some work, and I just want to have a look through this. So question gives you the equation of the line, which is great. We've got the equation of the curve, here. And first thing we need to do is to rearrange it so it looks like that, so we can write down the coordinate of A. So the student's taken the x out, which is good, and then factorises. So when that equals 0, x is 0, or there is a repeated root where x is 3. There we go. So the point A is 3, 0, which is correct. Then they want us to find B, which is up the top there. That's a maximum point, so we differentiate. Now this is the equation of the line here, so that's y equals, and the next line is where we have differentiated. So to make the communication clear, dy by dx equals 3x squared minus 12x plus 9. Divided by 3, brilliantly, to make life easier, to be able to factorise quickly. Got the points 3 and 1, and we know 1's already taken because it's on the x-axis. So 3 is already taken because it's on the x-axis, and when x is 1, y is 4. So that's your point up there, which is also correct. None of it's gone negative, so that's good. So we're literally, just to find the shaded region, we're going to integrate between 3 and 0. So if you don't put the 3 and 0 here, like the student's done, that's fine, but you must end up putting plus c at the end, okay? Again, I like the way this has been done because you increase the power by 1, divide by the increased power. Increase the power by 1, divide by the increased power, and then you tidy up and make it look prettier. 6 divided by 3 is 2. Perfect. Sub in the 3, sub in the 0. Nicely done. You get your answer. Okay, this is a slightly different one. Let me just, okay. A pretty weird shape is what we're looking for. But we have the equation of a curve and a straight line, and they cross at A and C. And we've also, the first part of this question says find A and B. So to find A and B, we just need to find the roots. So we need to find where this equals 0. So it's already factorised, which is great. So coordinate A is x is 1, and B is 0, and y is 0, and B is x is 5, and y is 0. So those are the two roots. To find the other part, then you have to solve the simultaneous equations where the straight line crosses, or the straight line in pink crosses the curve. So you make them equal to each other, make it, because it's a quadratic, make it equal to 0, factorise, find your solution. We've got x is 1, we already had that one, so that's fine, and x is 6 where y is 5. Right, so next part, how we work out the area. So I've redrawn it here. So the shaded area is shown by taking this triangle here, finding out the area, which is fine. And then after you've done that, and this is where it gets a little bit interesting, you have to take away this shape from here. You have to take that away from the big triangle that we've worked out. Now that shape is part of this curve and this straight line down to 6. So it's not a triangle. It might look a bit like a triangle, but believe me, it's definitely not a triangle. This shape has the curved side there, straight down. So integration is finding the area under the curved. If we integrated between 1 and 5 of the actual quadratic curve, we would find this area. It would be a negative answer of our integration, but it would be the area between the curve and the x-axis, which is what you must remember every time. It's between the curve and the x-axis. So all we need to do now is to find out the area of the big triangle, and as you can see, I think my student's done it right, half base times height. The base is all the way along to 6, so 1 to 6 is an area of 5. 5 times 5 is 25 divided by 2, because it's a triangle. And then we want to integrate the curve between 6 and 5. We've got x minus 1, x minus 5, with respect to x. Okay, so we're integrating under the curve. Yeah. So we're going to integrate between 6 and 5, x squared minus 6x plus 5 when we multiply out the bracket, which gives us increase the power by 1, divide by the increased power, increase the power by 1, divide by the increased power, x becomes to the 0, becomes x to the 1, between 6 and 5. Okay, so then we get, tidy up, x cubed over 3, oops, make it a bit smaller, plus 3x squared plus 5x between 6 and 5, sub in the 6, take away subbing in the 5, and you'll get your answers. So we want 6 cubed over 3 plus 3, 6 squared plus 5 times 6 minus 5 cubed over 3 minus 3 times 5 squared plus 5 times 5 gives you, once you work it all out, I think this is minus 6. I'm going to take away minus 8 1/3. Okay, so minus 6 minus 8, minus 6 plus 8 1/3 gives you 7 1/3, and then we're going to do 12 1/2 minus 7 1/3 gives you, oh, minus, there we go. Interesting. Hold your horses. So this is probably when my student had the issue, so I'm just going to use my calculator. Okay, 6 divided by 3 divided by 3 plus 3 times 6 squared minus 30 equals plus 30. So I'm getting this very different answer. Hold on. 6 cubed over 3 plus 3 times 6 squared plus 5 times 6. I've got 210. Ah, it's minus there. Silly me. Good. Minus. Okay, let's try again. Minus 6. So that's correct. And then if we go back and change the 6 for a 5, ooh, okay. See, it takes time to put things into your calculator. Oops. I get minus 25 over 3, which is minus 8 1/3. So then we've got minus 6 minus my answer, oops, which gives me my 7 over 3, which is correct. So then we've got the original 25 over 2 minus that. Which gives me 10 1/6. Which isn't what the answer gives. So I can see why he was having a problem. So if anybody else has come up against this question, by all means, enjoy. So if I'm now going to copy the mark scheme and hopefully explain where the mark scheme's wrong so that my student can understand. So let's have a look. Okay, pop in the mark scheme, pop that down there. Okay, so my issue now is looking at this mark scheme and seeing where the problem is. So we agreed with, so let me look at my other workings, we agreed with 12 1/2, so that's okay. We agreed with the minus 6 and we agreed with that. So it should be 12 1/2 minus, and here's the bracket, minus 6 minus minus 8 1/3, which means it's 12 1/2 minus minus 6. That all ended up as 7 over 3, so it should be 12 1/2 minus 7 over 3. What they've done is do minus minus, and then that should have changed to a plus, and then that's still a minus. So if we use our calculator to do 12 1/2 plus 6 minus 8.333333, we should end up with 10.16 recurring, or 10 and a sixth. So they have made an error by not changing that to a plus. Hope that makes sense. Thanks, Sandra. Bye.